In this video, we're just going to review some of the concepts from kind of our limit review chapter so that we are ready to take a quiz on it. So, this first little box here, we've got the limit as x approaches -1. Now, remember, the first thing you should always do with any limit is just try and plug the value in. So, -1 cubed is -1. Plus -2, so this is -3, plus 7 is 4, and the square root of 4 is 2. And that's the limit, and we're done, and we don't need to do anything else with that. So always try and plug it in first. We plug in 4, we have 5 multiplied by 16, minus 8, plus 3, so we have 80 minus 8, plus 3, so this is 75. Okay, next, going to infinity. So remember, going to infinity, this is where we usually would invoke the laws of dominance or the principles of dominance and just look for the highest power. So here, the highest power is on the bottom, so the limit is 0. Remember, if the highest power is on the top, there is no limit, or we could also talk about the fact that it's going towards infinity or negative infinity depending on the actual shape of the graph. If the high power is shared, if the same power is on top and bottom, then we make a fraction out of the coefficients. Next, 9 minus x over 3 minus the square root of x. Well, if I plug in 9 to this, I get 0 and I get 0. So I can invoke L'Hopital's rule. So let me rewrite the limit using L'Hopital's rule here. So x approaches 9. So the derivative of the top is -1. The derivative of the bottom is -1 over 2 square roots of x. Maybe you want to check that and remind yourself how we get that. Remember, we can rewrite this as x to the 1/2 power. Get rid of the root, bring the 1/2 out front. Using power rule, drop the power to -1/2, we get this. And the negative in front is just because it was 3 minus. So now we plug in 9 to this. Of course, the top is -1, and the bottom becomes -1/6. Well, -1 divided by -1/6 is just 6, and that's our limit. Okay, so by L'Hopital's rule. Next, if I plug in -3, I get 9 minus -3, which is 12, minus 12, so I get 0 over 0. So again, we use L'Hopital's rule. So we've got the limit as x approaches -3, 2x minus 1, and 1. And I plug in -3 to that, and I get an answer of -7. Okay. Now this next one looks like kind of a challenge, but remember, we're really looking at kind of overall behavior. So this square root of 36x to the 4th minus 9, if I could just kind of make a little note, that's approximately 6x squared. Okay? Because the minus 9 really is not going to affect this equation that much. So if it's approximately 6x squared, that means I've got 6x squared over 2x squared going to infinity. Well, the limit then would just be 3. Now, one thing to be careful of is if somehow with this being x to the 4th and this being x squared, we're never going to have to worry about negative numbers. So the answer here is just +3. But remember, with square roots, it is possible to be approaching a negative value because, if let's say this was 36x squared and 2x, so it became 6x over 3x, it's possible if the limit was going to negative infinity that the top, which would always be positive, will still be positive, but the bottom could be negative. So just be aware that square roots open up the possibility of 2 horizontal asymptotes. Okay, looking at the graph, the limit as x approaches 1. We are approaching a y value of 1 from both sides, and that is the limit. The limit as we approach 2 from the negative side is 2. The limit as we approach 2 from the positive side is 3. Remember, it doesn't have to actually have a value there. It just needs to be approaching there. The limit at 2, therefore, does not exist because the limit is not the same from the negative and positive sides. Finally, why is f not continuous at x equals 1? Well, there is a removable discontinuity at x equals 1. And the reason by the definition of continuity is that the limit as x approaches 1 of my function, notice that limit is 1, but that's not equal to the value of the function at 1. And I'm just going to make a note. The limit is 1, but the function's value is 2. And because those two things are not equal, the function's not continuous. Last thing I just wanted to review, finding the area included in polar curves. And remember, the first thing I would always do is draw a line from the origin to my point of intersection, such like that. And then I need to figure out what those intersection points are, and I can do that by setting my two equations equal to each other. So 3 plus 2 sine theta, this limacon, equals 2. Subtract 3 from both sides. I have 2 sine theta equals negative 1. Divide both sides by 2, so sine of theta is negative 1/2. Well, the sine of theta is positive 1/2 at pi over 6. It's so that's over here. 5 pi over 6 would still be positive, so this would be 7 pi over 6. Now, this other spot would be 11 pi over 6, but here's the problem. I'm actually going to want to integrate this thing going in this direction. And remember, it's important that the bounds on my integral go from smallest to biggest, or I will be sweeping through in the opposite direction. You know, if I wrote 7 pi over 6 and 11 pi over 6, I'd be doing this area. I'd be doing the wrong piece. And if I wrote 11 pi over 6 to 7 pi over 6, I'd simply be working backwards through the wrong piece. So I need this angle to be the correct angle so that I'm going from smallest to biggest. And the way to do that is just make this negative pi over 6. You also could use the fact that multiple angles end up at the same spot, and you could say, well, if I make this 11 pi over 6, I just need to make this 19 pi over 6. You could do that as well, just as long as you're going from smallest to biggest. So here's what I'm going to do. I'm going to integrate. We're going to have 1/2 the integral from negative pi over 6 to 7 pi over 6 of the limacon. So remember, it's 1/2 the integral of r squared. And let me just shade what that's going to give me. So I'm starting here. So it's going to give me all of that. Okay, so way too much. So then I'm going to have to integrate the circle. And that will give me this. And I will simply subtract those two, and that will give me my answer. And if you type that in, I believe the answer is close to 24. I'll let you type that in to make sure you can do that. But that is the way we would solve this polar curve area.